Hi, everybody. Today we're going to be doing proportions and we're going to solve them. They involve setting equal ratios and cross multiplying, which is really a specialized form of getting a common denominator. And then we solve them. There's going to be several examples and they're pretty easy. So let's get started, and they're really useful. So this is going to be solving proportions, which is C5. And what we're trying to do is get equivalent ratios here. There's several ways to do this. When I cross multiply, what I'm really doing is getting a common denominator. Let me show you why that is. I've got 24 over 44 is equal to V over 33. One way to get a common denominator is just to multiply your denominators together, which means that on this side, I would multiply 44 times 44 on the top and the bottom, numerator and the denominator. And on this side, I would multiply by 33 and 33. And as you can see, our common denominator is 33 times 34. And on the numerators, we get 24 times 33, which is really cross multiplying, and the V times the 44. Usually write 44V. In this particular case, we don't usually write the bottom part. We just simply cross multiply and say, okay, there's our numerators. Now, I left this alone on purpose. In order to get V by itself, I'm going to divide by 44 on both sides. And I didn't want to multiply these because it's really easy to see that 33 and 44 have a common divisor. I can divide by 11, divide by 11, and I'm already almost done. Now I can divide by 4 and divide by 4. And now I just multiply my numerators together and get V. V is equal to 18. And there you have it. So from now on, I'll just simply say I'm going to cross multiply, which gives me 8R. I multiplied the 8 times R and the 12 times the 2. Notice that I did on the other side this time. And I'm going to divide by 8. And I could do canceling, but this is 24 over 8, which is 3. D is equal to 50. I just cross multiply. Don't have to do any solving there. This time I get 30R. It's equal to 20 times 42. Divide by 30 on both sides. And we get, cancel the zeros. This is really dividing by 10. I get 3 goes into 42 14 times. 14 times 2 is 28. I didn't realize my coffee was going to be so loud. All right, we've got 33M is equal to 30 times 22. And again, we're going to have an 11 as our common divisor. So I'm going to divide the 11 into the numerator and denominator. And divide my numerator 3 into 30 to give me 10. And remember, we are talking about multiplication here. Gives you the 20. Now I have 8C is equal to 6 times 32. I could have went ahead and multiplied these, but it's easier to do it in steps. Let me show you what I mean. You see, well, in this particular case, I think for most people, 192 is not obviously divisible by 8, but 32, 8 goes into 32 really easily. and we get 24. Just seems a lot easier. Uh, 90 is equal to 6c. And when we divide by 6, we get 15. I didn't bother to write that one down. Okay, now we've got some big ones. So we've got 642. We definitely don't want to multiply these together first. Now, if you had a calculator, you could go ahead and multiply these together and then divide by your 798. Divide by 798 on both sides. And yes, you could use a calculator to do all this. It just so happens that I can see that 6 goes evenly into 642. That's 107. And if I divide this one by 6, 6 goes in here 133 times. Now, let's see. We've got 133, which doesn't have a lot of good divisors that I can see. I don't see anything nice that goes into 133. 107, nothing nice there. 532, let's see, 4 goes in there. Did I divide wrong? Let's see. 6 goes in, 107, yeah. 6 goes in, 133, yeah. Okay, a couple of things I'm going to think about. 3 is not a divisor for any of these. So I'm going to probably try to guess that 7 might work. 7 might go into 532, and it does. 7 goes into 532 76 times, and 7 goes into 133 119 times. And 19 goes into 76 4 times, which gives me 428. Seven is always a tough one. Hard to see your divisibilities there. All right, so now we've got 10g equals 7 times 680. And this time I'm dividing by 10 on both sides. And I have to multiply, sorry, that's an ugly g, 7 times 68, which is, put it on the side, that's 56, carry the 5, and 47, 476. So 27 times 35. And I know you're going to be tempted to grab your calculator and just do this that way. The thing is that it's almost as easy to put your 15 on the other side and notice that 5 goes into 15 3 times. And 5 goes into 35 7 times. And 3 goes into 27 9 times. And 9 times 7 is 63. What it does is it reinforces your multiplication and your divisions and your divisibility rules and all sorts of things. Number sense is important. It'll really help you later in the course. So you should always practice if you can. I've got 16 times 572 equals 704W. And 4 goes into 704. And 4 definitely goes into 16. So 4 goes into 704. Let's see. That's going to be 1, 7, 6 times. I'm dividing by 4, and dividing by 4 gives us a 4 right there. Now I can divide by 4 again, and 176 divided by 4 is 44. And I'm going to guess that 11 might go into 572, and it does 52 times, sorry. I'm dividing by 11, and 4 goes into 52 13 times. Kind of ugly, but it's good practice. Okay, we've got 4 times 164, and that's all we have to do. 4 times 164 is 658, 656. If I take 164 times 4, I get the 6, excuse me. Carry the 1, that's 25. Carry the 2, and that's 6. 16 times 18.7, 17n, and we're going to divide by 17. And here's what's going to happen here. I know that 17 goes into 18.7 1.1 times. It's because I practice multiplying by 11 a lot. And 1.1 times 16 is 176 with the decimal 17.6. We've got 9 times 3.2 is equal to 18t. When I divide by 18, I get 1 and 2, and 2 goes into 3.2 1.6 times. The 18s cancel. We have y is equal to 4 times 4.1, which is 16.4. uh, 17.5 times 4 is equal to 5y, and divide by 5. And all I'm going to do is just divide the 5 into the 17.5. It goes into 3.5 times. And then I multiply the 4 times the 3.5, which is 14. Just so you can see what I'm doing here. What I'm doing is I'm taking the 5 into the 17.5 in my head. 5 goes into 17 3 times. We know there's a decimal, and I know there's a 2 remaining. Now, a lot of times we like to do the long division algorithm, which means writing down the 15 and showing the subtraction. But in a lot of countries, they just simply multiply, think of the 15, subtract it in their head, and write down just the remainder. And then they can see the 25 more clearly. That gives us the 3.5. When I multiplied the 4 times the 3.5, what I was doing is I was multiplying the 3 times the 4, which gave me my 12, and the 4 times the half, that's 0.5, and getting the 2, which is 14. Another way to do 4 times 3.5 is called the double and half method. If I double this and take half of that, half of 4 is 2, and double 3.5 is 7. When I multiply those together, I get 14. So either method works really nicely for that. And so the answer, of course, is 14. This time we've got 15.9. Sorry, times 5 is equal to 5.3 times p divided by the 5.3. And I can see that 5.3 goes into 15.9 3 times. which gives me P equals 15. Could probably go a little faster, but I want to make sure you get them. I've got 16 times 11.7 is equal to 14.4 times T, and we divide by 14.4. And let me just write this equal sign a little further down. All right, we have to do a division now. Boy, I'm not seeing anything nice for 11.7. It just so happens that 3 goes into 11.7, and so does 9. The reason I know that 9 goes evenly into 11.7 is because I'm thinking of, there's a rule. It says that you add the digits, and if you add the digits 1 and 7, you get 9. And if you add the digits 1 and 4, you get 9. Now, one of the things I'm going to do is ignore the decimals. And the reason I'm going to do that is because this fraction that you see with the decimals in it can be simplified by multiplying by 10. What I'm going to do is I'm basically going to multiply by 10 on top, numerator, denominator, and I'm going to change it in my head. Now, normally I wouldn't write it out. I would just simply ignore the decimals. But what I end up with is this. Now, all I did was multiply this by 10 and multiply this by 10, and it moved my decimal over. Now, I know that 9 goes into 117. 9 goes in one time with 27 left. And 9 goes in one time with 54 left. 16. And the 16 simplify out. And I get 13 equals T. Oh, I said 13. Now, you want to take a look and see if it seems reasonable that if this one is a little bigger than that one, that this one should be a little, this side 16 should be a little bigger than that. And if it seems to be reasonable, it might be all right. Now I've got 4 times 12.4 equals 16V. I'm going to divide by 16 on both sides. And the 16, 4 goes into 16 4 times. And 4 goes into 12.4 3.1 times. And we're done. Now they give me a little extra here, and there's 2 ways to deal with this, and I'm going to show you both ways. Either one is correct. You can cross multiply this, and you get 70 is equal to 14 times u plus 2. Now, if you want to do more work, you can distribute the 14 to both parts. That gives you 14u plus 28 is equal to 70, and then you still have 2 more steps. You have to subtract the 28, and you get 14u, and 70 minus 28 is 42, and we divide by 14, and we get u equals 3. Perfectly acceptable method, probably the most common one. But I want you to notice something. In this very first step that I had, 70 equals 14 times u plus 2. The rule of solving is that you do the opposite to both sides in reverse order. In this particular case, we have the u being added to 2. Sorry, this is a u. Sorry, it's a little ugly there. Yeah, I can't seem to be fixing it. U is being added to 2, and then I'm multiplying by 14. In order to solve it, I want to undo those steps. So I'm going to divide by 14 on both sides and get 5 is equal to u plus 2. And then I'm going to subtract the 2. And I think you can see that this is quite a bit simpler. And of course, you get the same answer either way. So I might alternate the methodology. We have 15 times q plus 1 is equal to 60. Divide by 15 on both sides and you get q plus 1. 15 goes into 64 times, and subtract the 1, and you get the 3. I know you guys are used to seeing the division by 15 on both sides and the subtract the 1 on both sides. But in a lot of textbooks and a lot of times you'll see people just simply understand that that is what they're doing. This is 3. Now we've got 6 times a plus 1 is equal to 18 times 5. Dividing by 6 on both sides gives us a plus 1 is equal to 3 times 5. All I did was divide by 6 on both sides. And now I'm going to subtract 1 from both sides. And 15 minus 1 is 14. Now I've got 9 times p plus 2 equals 15 times 6, which is 90. Dividing by 9 gives us p plus 2 equals 10. And subtracting 2 on both sides gives us p equals 8. Twelve times f plus 4 is equal to 3 times 32. I should have probably multiplied that out. I'll go ahead and multiply this one. 12f plus 48 is equal to 96. Subtract the 48. You get 12f is equal to 48. Divide by 12 and you get our f is equal to 4. And you can check it. F is 16 times 12 and 3 times, wait a minute, 8 times 12 is 96 and 3 times 32 is 96. There we go. All right, we've got 36 times 44 is equal to 48 times s plus 19. Now I'm going to make this a little easy on myself by dividing by the 48. And I'm going to leave my s plus 19 over here for now. Dividing by 4, which is 1, 12. Divide by 4, which is 11. Divide by 12, which gives me 3. And 3 times 11 is 33. I'm not quite done. I still have to subtract the 19, which gives me 14, doesn't it? I'm just subtracting 19 from both sides. And 120 equals 30 times e plus 1. Very common mistake is to forget your parentheses. Don't forget your parentheses. They do matter. Divide by 30 and we get 4 is equal to z plus 1. Subtract 1, you get z is equal to 3. And we're done. And 21 times f plus 8 is equal to 36 times 14. Divide by 21 on both sides. Our f plus 8 is by itself. And 7 goes into 21 3 times. And 3 goes into 36 12 times. And 12 times 2 is 24. Subtracting 8 gives us f equals 16. Oh, this is endless. Okay, so 20 times 35 equals 25. Guess they want to make darn sure I got it. G plus 18. So I'm going to divide by 25. And my G plus 18 is by itself. And 5 goes into 25 5 times, into 24 times. 5 goes into 5 once, and into 35 7 times. Get 28. Subtracting 18 gives us G equals 10. I just subtracted 18 on both sides. There it is. Man, that one took a little while. Usually takes about 28 to 30 problems, but it wasn't so bad. Like I said, good practice. Don't just grab your calculator and turn your brain off. It's never a good idea. I hope you have just as easy a time as I did, and good luck.